Welcome to another part of the ISM Exercise Set Microeconomics, this time with a unit on Polypolies. Let's have a look at the exercise. Here we have an automotive supplier who faces the following cost function. That's 1/2 q squared plus 50. And on the market there is a price of 20 euros for the offered part, so the part which he and other companies provide. Our tasks now: A. Determine the marginal and average cost curves as well as the fixed and variable costs. B. Determine the company's profit maximizing output. C. Calculate the profit in case D or a company realizes the profit maximizing output. D. Determine the combination of market price and quantity that will be realized in the long term. E. How many companies will remain in the market in the long term if demand is determined according to the following function. So the demand function here is Q being equal to 230 minus P. And F, determine the prohibition price and the saturation quantity of the market. Okay, let's work our way through this step by step. So we can start with marginal and average costs. So for this we need the cost function, that's repeated here. And then for the marginal costs first, we just take the first derivative thereof. Well, the 50 we skip because there's no q with the 50. And then we have the derivative of 1/2 q squared. So that's 1/2 times 2 times q. And that's basically only q. So the marginal costs are q. And for the average costs, we basically only take the cost function and divide this by the production, so we divide this by q. So then we have 1/2 q plus then only 50 divided by q. So that's the first part. However, in this part we are also been asked to determine variable and fixed costs. Well, the variable costs, that's the part of the cost function which depends on the quantity q. So here that's the 1/2 q squared. Finally, then there's only one part left, that's the fixed cost. Well, the fixed cost, that's everything else of the cost function. So in particular, this part, which is not dependent on the quantity q. So here, it's the 50. That's everything there is to be done about this first part of the exercise. And that's also everything we need to continue with the second part, where we are tasked with finding the profit maximizing output for a company. Whenever you read something about profit maximizing output, but you don't read anything about long term, and the exercise in some way states a price, then you can just determine this profit maximizing output by setting the price equal to the marginal costs. So here we have a price, that's 20, and we have the marginal cost as Q. So, well, this already states the profit maximizing output of being 20. Well, that was pretty easy, so to speak. Okay, we have the price, we have the quantity. So quantity and price are 20 here. And if we have both of these values, we can directly calculate our profit of a company. For this, we recall profit, that's revenues minus costs, with the revenues being quantity times price. So we go here, quantity times price, so 20 times 20, minus the costs. And the costs we get if we insert the quantity into the cost function. So then it looks like this, 20 times 20 minus, in parentheses, the costs. So 1/2 times 20 squared, that's a 400, plus 50, leaving us with a profit of 150. That's done already, part C. All of this is for the situation where our price is 20. Well, here in this case, we have a positive profit. So we know in the long term, which is actually the next part to be covered, we will get a different price, a different quantity, because in the long term, the profit will be 0. That's always the case. Okay, in particular, we know that if the price now is 20, we have a positive profit. In the long run, the price will be lower. That's something we can keep in mind to check our next result. So let's continue with D, with the long-term equilibrium. Whenever you read long-term, this means we are setting marginal costs equal to average costs. Here our average costs were 1/2 Q plus 50 by Q, and marginal costs were Q. So we solve this for Q as well. So first we go minus Q half, leaving us with 1/2 Q being equal to 50 divided by Q. What we are doing now is basically multiplying with Q and multiplying with 2, which leaves us with Q squared being equal to 100. And here we take the square root, leaving us with a result of 10. The negative result of minus 10 we skip because minus 10 cannot be produced. So here we have the long-term quantity, long-term profit maximizing quantity. And to get the corresponding price, we insert this quantity in either the average or the marginal cost. Easiest here in this case would be the marginal cost, so we get directly a price of 10 as well. So we have the long-term price and the long-term quantity. And if we have this, we can directly start with part E, where we've been asked how many companies will establish themselves in the long run. And well, how do we get to this? Well, we know each company produces 10 units. However, how many units are actually required by the market? So for this, we need the total market demand. And we get this by inserting the price we calculated in D into our demand function. So how many goods do the customers want if the price is at 10? So we insert the price into the demand function and get here a total market demand of 220. So the whole market wants 220 pieces. Each company provides 10. So we get the number of companies which will form by dividing the 220 by 10, the output of one of the companies. So we get a total of 22 companies which will remain in the market. And this was already, well, the last part with particular focus on the companies. We still have, however, one part to go. That was about prohibition prices and saturation quantity. And well, if we think about this, we can recall that both of them are intercepts with regard to one of the two axes, or intercepts or nulls with regard to one of the two axes. In particular, the prohibition price is the price when nothing is bought anymore because the prices are too high. Okay, so what does this mean? This means that the quantity falls to 0. The demanded quantity. So that's a price where customers no longer want to buy this product. So what we're doing is basically calculating the null of the demand curve with regards to the p-axis. Or in other words, we insert Q equal to 0 into the demand function. If we do this, we get here directly a prohibition price of 230. And well, saturation quantity, that's similar, but more or less exactly the opposite. So that's the quantity which is demanded if the good is for free. So we're not inserting Q being 0, but we're inserting the price being 0. So we insert P being 0, and we get the null with regards to the quantity axis. So here in this case, this would be Q being equal to 230. And that's our saturation quantity. And well, that's all there is to this exercise. And I hope you enjoyed listening to it. And if you want to see more exercises, feel free to visit the rest of the exercise set or have a look at the corresponding playlist. I say goodbye and see you next time.